Finally, the work is done. Let me just call my friends for the lunch today. Hey, hi Rihanna, let us all meet for the lunch today. What do you say?
Hi Piyush, yeah sure. So let me ask Vedant, then I'll let you know.
Yeah, that'll be cool. Let me know.
Vedant. Hi Vedant, so would you like to join us on lunch today?
Hi Rihanna, sure. Let me just check with Chirag and I'll let you know.
Okay.
Hi Chirag, would you like to join us on lunch today?
Sure. Let me check with Ajay once and confirm.
Alright, thanks.
Hey Ajay, would you like to join us for lunch today?
Hey, hi Chirag. Sure. See you at the lunch.
Okay.
Okay, bye.
Hey Vedant. I will be there for the lunch. Okay.
Alright, thanks. Hi Rihanna, see you at the lunch.
Yep.
Hi Piyush, so see you at lunch.
Alright,
Okay,
see you.
bye.
What you just saw right now was a real life example of recursion. You see, each person's response was dependent on someone else. And Ajay, in this case, was what we call a base case for a recursion to get resolved or to return a value. Similarly, in a recursive function, a function keeps on calling itself until it reaches a base case that returns a response so that all other function calls before it gets resolved as well. Let's better understand this scenario by replicating it with our code. So I'm going to take 5 functions over here, and each function will represent a single person. So let me write this out real quick. Just like this. So as seen before, it all started with me. So, okay, I'm gonna call this function over here. Right. So I'm calling Piyush over here, and Piyush is calling Rihanna for asking for lunch, right? But the response of Rihanna is dependent on someone else, that is Vedant over here. So she is calling Vedant right now. But the response of Vedant is dependent on Chirag, and Chirag's response is dependent on Ajay. So as you can see, these functions are calling some other functions, and the response of that particular function is dependent on some other entity or some other function, right? But in this case, Ajay is base case. So this is what we call base case, and this is what is responsible for resolving a recursion, as the recursion will keep on going, right? So Ajay responds with true. So all of these other functions will also respond with true. If it responded with false, then all of them will respond with false, right? So if we just try to run this, node recursion basics, and yeah, obviously I haven't console logged this. Now if we try to run this, yep, you're gonna see we get true over here. That is, Piyush in the end will return true because all of the other functions did return true. But then you will say, how is this related to recursion? Isn't recursion about a function that keeps on calling itself? But here you have written multiple different functions. Yes, you're right, and this is just a representation to show you how a recursive function will work when we go on to convert this scenario into an actual recursive function. But first, let's see how a normal recursion looks like. So I'm going to comment this out, and I'm going to create a function over here called recursive function. And inside of it, I'm just gonna say recursive function, because that is what recursion is all about, right? It calls itself, like it calls the function. Okay, so I'm just gonna call this function once, and then this is gonna keep on calling itself. Let's just console log it over here. I'm gonna say called. Let's see how many times this get called. And as you can see now that we are stuck in an endless loop, that this is being called again and again and again and again. So this is the exact reason why we need a base case to stop a recursion. So how do you add a base case? So let's say this is going on, right? So to add a base case, we have to add an if condition or any sort of condition. So I will say if this is true, then return something, right? It can be anything, like it can be one particular condition that breaks this recursion. Else this is gonna keep on looping forever. So let's get back to our previous example, this example, and let's try to recreate it by using a recursive function. So what I'll do is, I'll just name this as, let's say, go to lunch. And we're gonna start with the first person, right? So I'm just gonna provide it 1 over here. And I'm gonna say person. So we have total 5 people over here, right? As soon as it reaches the 5th person, I'm gonna break it. So this is 1 by default. So I will say if person is equals to 5, then return true. Else, we're just gonna call it with person plus 1, because obviously we're gonna move to next person, right? And I'm just gonna console log it over here, just the value of person to see where we are currently. And I'm gonna console log this one over here as well. I'll just say outcome to know what's the outcome of all of these calls. And yeah, I think let's try to run this. And oops, my bad, I need to return here as well, right? So that it returns the value to the previous functions as well. So now if I try to run this, yep, you're gonna see first person, second person, third, fourth, and as soon as it reaches the 5th person, it returns true, so that all other previous functions can also return true. Now I know this might be a little bit hard for you to understand it one go, but don't worry, as we move forward in this video, you're gonna get a much more clear understanding as we discuss more and more example of recursion. Now I know you might be thinking, why do we need recursion in the first place? So recursion is a very important topic when it comes to a lot of algorithms such as tree and graph traversal algorithms, a lot of sorting algorithms, divide and conquer algorithms, backtracking algorithms, dynamic programming, and much more. So recursion is a very ground level important topics for what is about to come in this course and data structures and algorithms in general in JavaScript. So let's see an example on how you can convert a function that is written by using for loops into a recursive function. So we have this function over here called multiply, which takes an array, and what it does is it multiplies all of its elements. So if I console log multiply and provide it with a simple array, let's say 1, 2, 3, 4. Right? And now if I try to run this, you're gonna see we get 24. So 4 multiplied by 3, 12, 12 to the 24, 24 into 1 is 1. So we get 24 over here. Now we are using simple for loop over here and multiplying each element with another. So how do we convert it into a recursive function? Okay, let's comment this one out. What I'm gonna do, I'm gonna write another function called multiply, which again will take an array. And now what are we supposed to do over here? So in this for loop, what we were doing is we're taking an global state called product, which was by default 1. And for each iteration, we were multiplying every single element into that global result. But in recursion, we don't have any global state as such. So what we can do is we can divide this problem into small parts, and then we can multiply them all together. So let me show you. So what we can do is we can say return, and we can take the current element, that is the last element or the first element. So I'm going to take the last element, which in this case is going to be array dot length minus 1. So I've taken this last element over here, and what I'm going to do, I'm going to multiply it with rest of the result, because that is what we're supposed to do, right? If we have 1, 2, 3, 4 as an array, we're supposed to do 4 multiply by 3 multiply by 2 multiply by 1, right? So in this case, we have accessed 4 over here. Now how do we access 3? What we can do is we can simply call this multiply function, and we can provide it array and remove one element from the array. Array dot slice 0 comma array dot length minus 1. But wait, there's going to be one moment where this array becomes empty, right? The length of this array becomes empty. So I'm gonna put an if condition over here. If array dot length is less than or equal to 0, then I'm gonna return 1, because there's nothing to multiply over here, right? So I'm just gonna return 1. Else we're gonna do this. I think this should work. Let's find out. Yep, you see we get 24 over here. So let's deep dive what's going on over here. If right at the beginning I try to console log the array, you're gonna see, and now if I try to run this, you're gonna see first we have 1, 2, 3, 4 in the first call. We have 1, 2, 3, 4. Then in the second call, since the array dot length is not equal to or less than 0, we're gonna go to this line over here. We're gonna take the current element, that is 4. Let me just explain with this. So we currently have 4 over here. 4 multiplied by this, multiply with array dot slice 0 comma array dot length minus 1, that is 0 to 3. So this will be 1 comma 2 comma 3. This is what we're gonna call. So now we have multiply with 1 comma 2 comma 3. Again, length is not equal to or less than 0. So we're gonna go to this statement again. Now for this function call, what will be the scenario? It will be array dot length minus 1, which is in this case 3. So I will say 3 multiplied by this multiply function. But again, we're gonna slice to array length minus 1. So now this will be 1 comma 2, right? Now again this will evaluate this one. First of all, let me just take this and replace it over here. So now we are at over here. Now again it's gonna take the last element, that is 2, and multiply it by multiply, and now array will have 1, just like that. And again when we call this, then we will have 1, and then we reach the base case, which is if array's length is less than or equal to 0, which is going to be again something like 1, right? So then we're gonna return 1, and now we're gonna return each and every value for this recursion, and we're gonna multiply them, all of them together, right? So that is when we will get our final output of 24. So yeah, that is how a basic recursion works. Now you might be thinking, which one is better? Is the looping approach better or the recursive approach better? So to be honest, there's no right or wrong answer to that. It's up to you and depends on the particular problem that you're solving. When it comes to writing code, you have to make sure that it's easy and understandable to read. And recursion can sometimes result in a shorter and more simpler code. So that is why we emphasize on using recursion a lot. And that is why I have a question to ask you. Why did a programmer go broke? Because he kept on calling himself and his bank account reached the base case of value 0. Because he kept on calling himself and each version of him spent that money. So, there was a one point it reached 0. Never mind. Alright, now let's see the most asked recursion questions that are asked during our DSA interviews. So the first one will be factorial of n. So what is this factorial all about? So when we have a number, which in this case will be n, so let's say n equals 5. So factorial of 5 will be 5 into 4 into 3 into 2 into 1. So I'm going to get a function called factorial, which will take n as an input. And now we're supposed to return the factorial of this function. So I would highly recommend you to go and try this question yourself first, because it's very similar to the previous question that we just did. So yeah, pause the video and try this question yourself and then continue with this video. So okay, I hope you've done this question. If not, let's continue. We have a function called factorial and we're taking n as an input. So if we say console log factorial, and let's say we take 5 as an input, right? Now right now we have 5 over here. So I'm gonna say return n into, so as you can see, whatever the value of that number is, that is multiplied first, right? I mean, that is the part of our calculation. So what I'm gonna do, I'm gonna say n multiplied by whatever comes next, right? Now what are we supposed to do? We're supposed to do n minus 1. So can I just not take this function and call it again with n minus 1? Simple, right? So now it's going to be 5 into n minus 1, which is going to be 4 into 3 into 2 into 1. But again, we have to take care of our base case. So what can be the base case in this? So as soon as this reaches the value of 0, we're going to return 1, because it's not going to go any further than that. So I'm just going to simply say if n is equal to 0, then just return 1. Because if you multiply anything by 1, it won't make any difference, right? So that is why I'm returning 1 over here. Else you can return n into factorial n minus 1. Cool, let's try to run this. Alright, we get 120 over here. Let's see. So 5 multiplied by 420 into 3 60 into 2 120. Okay, fine, we have 120 over here, and that is what we're supposed to get. Awesome. Now the next question is range of numbers. So in this question, we're supposed to create an array with the range of the provided number. So we're gonna get one start variable, and other the end variable. So as you can see, we have this start num and end num, and we are calling this range of number from 0 to 5, and you have to use recursion to do this. So again, I would highly recommend you to solve this question yourself first and then move on with this video. So I hope you were able to do this. Let's see how we can do it. So first of all, we're gonna check the base case first. So obviously the start number has to be less than end number, right, to generate it from start to end. So simple, we're just gonna use our common sense and say if end num is less than start num, then it makes no sense to continue. So this is going to be our base case. If that's the case, then I'm gonna simply return an empty array, because there is no chance that we can just generate another array, right? Else what we can do is we're gonna say const numbers variable, and I'm gonna say range of numbers. We're gonna call this function again with start number and end number minus 1. So with each iteration, with each recursive call, so if we have end number as 5, so it will be 4, then 3, then 2, then 1, then eventually 0. So it will go below start number, right? And as soon as that happens, it's gonna return us an empty array. And since this is going to return us an array over here, this numbers will be an array. So I will simply say numbers dot push and push the current element, that is the end number. So end num over here, and I'm just gonna return numbers. Let's try to understand what's going on over here. So if I try to dry run this, so first of all, we have range of numbers with 0, 5. Now in this case, the end num is not less than start num, yeah, obviously. And over here, we are calling this function again first. So okay, fine. We're gonna call this function again, start num, which is going to be 0, and end num will be 4 in this case. First it was 5, then it was 4. Then again it's gonna go back. So end num less than start num, no, that's not the case. So again it's gonna come back over here, it's gonna call this function again. Fine. I'm gonna call this function again, but this time it's gonna be 0, 3. Similarly, it's gonna be 0, 2, and then in the end, it's gonna be 0, 1. Let me just write all of these in separate lines. Alright, cool. I think it's clear up until this point. Now after this, again, it's gonna call with start num and end num minus, oh, my bad, this is not 0, this is 1 actually. Yeah, sorry for that. Now after this iteration, it's gonna go over here with 1 and 1. And okay, this is still satisfies the condition, but in this case it will be 1, 0. Right, now in this case what's gonna happen, it's gonna satisfy our base case. So end number is less than start number, it's 0 less than 1. Fine. So what we're gonna do, we're gonna return empty array. Fine. In this scenario now we get an empty array in this numbers over here. So we can do numbers dot push end num. So in this case end num was 1. So we just pushed 1 over here. Right? Cool. We get 1 over here, and then we're gonna return numbers. Simple. So numbers in this case is this 1 array. Now we're gonna go to this case. Now in this case we get in numbers this array with value 1. Now after this we're gonna say number dot push end num. Now in this case end num was 2. So I will say 1, and I'm gonna push 2 over here. Simple. Again it's gonna return numbers, and in this case end num is 3. So I will say 1, 2, 3. Similarly in this case end num is 4, 1, 3, 4. In this case it's 5, 1, 3, 4, 5. So you see how this bottom up approach worked. We went to the very end of the array, and then it returned us with an empty array, and then we started adding elements to it in a reverse manner. So we first added 1, then 2, then 3, then 4, then 5. So this is the beauty of recursion and how simple it gets while writing code with recursion. I know it might be a little bit complex, but with time, as you would have written a lot of recursive code, you're gonna understand this very easily. Alright, now in our next question, we are given an integer x, and we are supposed to return true if x is a palindrome and false if it's not a palindrome. So what is a palindrome? So I've explained this question in a much in-depth in this video right over here. So I'm gonna play that clip over here for you to understand. So palindrome number is a number which reads exactly the same when you read it forward or backward. So if this is 121, so if you reverse the number 1, 2, 1. So it's exactly the same as it was forward as well as backwards. But that is not the case with 10. So if you read 10, it's 1, 0. But if you read it in reverse manner, it's 0, 1. Therefore, in this case, output will be false. But in the first case, output will be true. So up until this point, what we were doing was more of example of linear recursion, that is recursion in one single line. But with this question, this Fibonacci numbers question over here, we're going to see an example of recursion where multiple recursive calls are being made at once. So what is a Fibonacci number? So in Fibonacci number, we're given a number n, which let's say in this case is 5, right? So how does this Fibonacci series works? So we start with two numbers, 0 and 1. Now to get the third number, we add 0 and 1 and we get 1. Now to get fourth number, we add previous two numbers, that is 1 and 1, 2. Now to get fifth number, we add third and fourth number and so on. And as you can see over here, to get f of n, we're supposed to add f of n minus 1 plus f of n minus 2. And trust me, this is a very frequently asked question when it comes to data structures and algorithms interviews, when the interviewer is looking to ask you a question regarding recursion. So before jumping into the code, let's understand how this will visually look. Oh no, you're not gonna explain this algorithm when Algo Agarwal is here, because people would like to see this algorithm explained visually, and that too from Algo Agarwal. So let's get it. Let me explain you Fibonacci number, how to do Fibonacci number by using recursion in the most easiest way possible. So let's see. What is a Fibonacci number? As explained, Fibonacci number can look something like this. So if we want to calculate what's the Fibonacci number for 5, so okay, Fibonacci series looks something like this. It starts from 0 and 1. And to calculate the next numbers, we have to add the previous two. So 0 plus 1 equals 1. Fourth number will be 1 plus 1, 2. 2 plus 1, 3. 3 plus 2, 5 and so on. So the fifth number will be 1, 2, 3, 4, 5. So 3 will be the final output when the input is 5. Alright. So let's see what are the steps that we are going to take to explain this. So let's say we have a function called fib, which takes an input of 5. So let's see the rules first. See, as I mentioned, it starts with 0 and 1, and the index of our array also starts from 0 and 1, right? So what are we going to simply say? We're going to say if the input that is provided to us, if it's either 0 or if it's 1, if it's index 0 or if it's index 1, then we're going to simply say return that. So I will say if n, we're considering n in this case. So let me just remove this. I'm just gonna write n over here. So if n is less than or equals to 1, that is if it's 1 or if it's 0, then obviously we're gonna return n, right? Simple enough. But if that is not the case, what are we gonna do? We're gonna call this function again, but this time let's say if our original number was 5, if we want to calculate the fifth position. So for fifth position, it's going to be the Fibonacci number that comes before it and the number before that number. That is the sum of previous two numbers. So what do I mean by that? Okay. If that is not the case, we're gonna say else return what is the Fibonacci number of n minus 1 and add it with the Fibonacci number of n minus 2. That's the logic, right? If you're supposed to calculate this position, right, fifth position, then you need to know only the previous two. That's it. You just need to know the previous two and you'll be good to go. You can calculate this. So that is all we are going to do. And this is what our algorithm is going to be. It's that simple. Let me explain you guys with much easier visual approach. So okay, over here we have a Fibonacci number function with 5 as an input. So what we want to do, to calculate 5, we just need to calculate the Fibonacci number of 4, that is n minus 1, and Fibonacci number of 3, that is n minus 2. Simple as that. Yep. Now we need to calculate the Fibonacci number of 4 over here. So how do we do that? Again, same thing. We need to calculate the Fibonacci number of 3 and the Fibonacci number of 2. Simple as that. Same with here. Fibonacci number of 2 and Fibonacci number of 1. Let me just write this out. Same for this one as well. Alright, cool. So there it is. There's the table. I know my handwriting sucks, but please forgive me for that. So let's see what's going on over here. On all of these cases, we have reached our base cases. This is our base case, this, and this as well. So our base case is if n less than or equals to 1, just return n. Okay, so this is 1, that is less than or equals to 1. It is 0, less than or equals to 1. Okay, so this function over here will return 1. This function over here will return 0. This function over here will return 1. This one 0, 1, 1, 0, 1. Cool. Now that it has returned all of these base cases, now what's gonna happen over here? We know we need to add both of these. So to calculate Fibonacci number of 2, we need to add this plus this, as you can see over here. So 1 plus 0 is going to be 1. So this function right here is going to return 1. So where else is Fibonacci 2? Okay, this will also return 1. This will also return 1. And yeah, I think that's it. Okay, cool. Now let's focus on this part. Fibonacci number of 3. We know the result of this. We know the result of this. 1 plus 1, 2. So we're going to return 2 over here. Okay. 1 plus 0, 1. Oh, we already calculated that. Over here 1 plus 1, 2, so this is going to return 2. In the case of Fibonacci number of 4, we're going to return 2 plus 1, that is 3. And finally 3 plus 2 is going to be 5. So Fibonacci number of 5 will be 5. Apologies, I mentioned that Fibonacci number of 5 will be 3. That is not going to be the case since we start counting from 0. So 0, 1, 2, 3, 4, 5. So this is what is going to be Fibonacci number of 5. So yeah, that is what Fibonacci number is all about. I hope you liked my explanation. If you did, hit that like button right now. And I will see you in some time with the explanation of some other algorithm. This guy, man, he always interrupts my videos. If it weren't for you guys, if you guys weren't liking the way he explains, I wouldn't allow him on my channel. Anyways, let's move on and I'm gonna now write the code for this explanation. But first, before moving on to writing the code for the recursive approach, I'm gonna show you how you can do it by using just for loops. So first, we have taken an array ARR with initial values of 0 and 1 because obviously we start from 0 and 1, right? And then we're gonna run a for loop from I equals 2 because we already have 0 and 1, right? So we're gonna start from 2 and we're gonna go to all the way to n. So as we traverse further, if the I is 2, we're gonna say array I minus 2 plus array I minus 1, that is adding previous both values, right? And this is how we're gonna populate our array with all of these values. And in the end, if the n is equals to 3, we're gonna return whatever is in the third index of that array. So let's find out. Run this real quick. If I say n equals to 3 and run this, you're gonna see we get 2 over here. If I change to 5, let's say, then we're gonna get 5 because in the fifth index, that is 1, 2, 3, 4, 5. Oh, I mean 0, 1, 2, 3, 4, 5. Fifth index, we have 5 over here. Alright, but we're not gonna use for loop, right? We're not gonna do this the old-fashioned boring way. So we're gonna use recursion to rewrite this code. So I'm gonna take this function and I'm gonna say function fib recursion. And we're gonna take n as an input and let me just comment this one out for now. Alright, so as explained by Algo Agarwal, what are you supposed to do? Since we already know that if n equals to 0, then it's gonna return 0. But if n equals to 1, it's gonna return 1. So we already know what our base case is going to be, right? So I'm simply gonna say if n is less than or equals to 1, then simply return n. Simple, right? So that is what our base case is going to be. And now here we're gonna branch out this into two different recursions. So I'm gonna say return fib recursion to n minus 1 plus fib recursion to n minus 2. And this is gonna form that complete tree that you just saw. And in the end, it's gonna add all of the values together. Cool. So let me just try to run this recursion and run it. Yep, you see, we get 5. If I say 3, run it. If we just add a pretty big value, then it's gonna give the result accordingly. Yep. Great. Now let's move on to our next question, which is reversing a string. So again, what I'm gonna do, I'm gonna take a function over here called reverse string, and this will obviously take a string over here. So what are we supposed to do in this? We're gonna input a string and the output is going to be the reverse of that. So if it's HELLO, the output will be OLLEH, right? So obviously, before moving forward in this video, you have to go and try this out yourself first. So I hope you were able to do it. If not, let's find out how to do it. Alright, so we have a string over here, right? And what are we supposed to do? We're simply supposed to take one character from it at a time and just put it at the back of the string. But we are supposed to do it by using recursion. Okay, so let's say we have hello over here. We can simply take H at once and we can put it over here, right? Plus this. And then we can supply this remaining string back to this function. And then it's again going to put the logic that we're going to take the E and just put it over here, right? So how can we do this? Let's see. I'm going to say return reverse string, and I'm going to simply take the string which was provided to us dot substring. Now you might not be familiar with these functions right now because I haven't made a video on strings yet, but don't worry, that video is gonna drop very soon. But I'm gonna explain you what this function does over here. This substr function, what it does is we are supposed to provide it a number. That is the starting position of the desired substring. So the index of the first character in the substring is 0. So what it will simply do is, if we provide it with 1 over here, so what it will do is it will start from 1 and it will take the complete string just like this, right? And then what we can do is we have taken this string and then we can put H at the very last. So we can take the first character now. So I will say str dot, there's a function called char add. So what char add does is it returns the character at the specified index. So we need the first index, right? So we're gonna say 0. That's it. That is all we were supposed to do. But wait, we haven't written the base case over here yet. So there's going to be one point, right, where all of the characters of this string will be exhausted and we will be provided with just an empty string. Also, hold on, I've just written it inside of this bracket. This is how it's going to be. It's going to be outside of that function. Yeah, so it's gonna at one point exhaust the complete string, right? So we're supposed to say if str equals to empty, then we're gonna return empty, right? Else we're gonna do this over here. Don't worry, I'm gonna dry run it as well in just a second. Let me just console log this and run this. Reverse string hello. And if I run this, yep, we get the reverse of this string. So let's see what's going on over here. So we have this hello over here, right? In the first iteration, this is hello. Okay, so in the first iteration, we're calling this reverse string function starting from the index 1. So what this will do is this will call reverse string starting from 1. So ELLO, right? And then we are adding the first character, which is in this case H plus H, right? That is what we're going to do. Now let's talk about this. What will this result in? This will result in starting from index 1, so it will be LLO plus E, right? Similarly for others as well. Let me write this out real quick. Yep, just like that. So we've reached over here, right? And now we're calling reverse string with the empty string. So when we call it with the empty string, then this is going to return with the empty string, right? Okay, let's replace it with the empty string then right over here. So empty string plus O will obviously return us O, right? Now this thing is returning us O. Cool, let's just take it and replace it over here. O, right? So O plus L will be OL, right? So this LO is returning us OL, fine. I'm gonna remove this and replace it over here. OLL, fine. Let's take it and replace it over here. Let's take this and replace it over there. So you see, this is how you get a reverse string by using recursion. I hope now you must be able to find recursion really easy, right? Because now you're able to think how recursion works. There is a pattern if you see these questions, right? You're supposed to call these functions and there's always going to be a base case, and this base case is usually very obvious. If you just put a little bit of common sense, you're going to understand how easy it is to find the base case. And once you find the base case, I think it's pretty much easy to, do the recursion based questions. And this next question is called subsets. And trust me, this has been asked to me multiple times in the past during DSA interviews. So I would need your full focus to understand this problem. So okay, let's see. Also, one more thing, that this is an example of what we call a backtracking algorithm, which we're going to talk about in depth in our future videos. But for now, you're going to get a brief understanding of what backtracking algorithm is and how you can implement it using recursion. So we've been given an integer array nums of unique elements. So we're going to have a array just like this with unique element, that is no element will duplicate itself, right? So we're supposed to return all of the possible subsets, that is the power set. Now what is the power set? So we have this array over here as an output, and this will contain all of the possible combinations that this particular numbers can create. So as you can see, we can either create a combination of an empty array, okay, or we can have 1 2 1 2 3 1 3 2 3 1 2 3. So these are all possible combinations. Now keep one thing in mind, 1 comma 3 and 3 comma 1 are absolutely same. So it doesn't matter, the sequence doesn't matter if both of the numbers exist, or if the unique number exists in a single array. So don't think 2 comma 3 and 3 comma 2 as separate entities, because they're the same. So that is why the solution set must not contain the duplicate subsets. It should contain only the unique subsets. And also solution can be returned in any single order. So let's try to first understand this problem in a visual format. And no, I'm not giving you Algo Agarwal this time. I'm gonna explain you this in a visual format.
Guess who's back?
Yep, Algo Agarwal is back. Let's continue. So let me explain you how you can efficiently write this subsets algorithm, and let me explain you visually how this is going to work, because this is a pretty complex algorithm and you need an expert like me to explain you, not some noob like roadside coder. Alright, so okay, cool, let's get started. So we have been given an array over here, right? Let's say we can say it's 1 2 and 3, and we are supposed to generate the all possible combinations of this array, that is all possible subsets that this array can create, right? So let's see what is the approach that we are going to take. So we are going to take two global variables, first the result and other is the temporary variable or the temp array, and then we have this function called recursive. Now inside of this, the approach that we are going to take is this. So by default we have an empty temp array, okay? So we're going to take an empty temp array over here. Fine. So now what the approach that we're going to take is, now amongst all of these three, to create a subsets, either a subset can include one or it cannot include one, right? Similarly, either it can include two or it cannot, it can include three or it cannot, right? So that is exactly what we're going to do. Every time we're going to make two recursive calls. In one recursive call, we're going to say, okay, take one. But in the other one, we're going to say, no, don't take one. So let's say to create our first subarray, we're going to say take 1. So we have added 1 into this array. Fine. And the other array remains empty. Cool. Now similarly, we are going to do for 2 as well. For all of these, we can either take 2 or we cannot take 2, right? So now our array contains 1 comma 2. And this array doesn't contain 2. So it's just 1. Similarly, here as well, it can either take 2 or it will not take 2 and it remains empty. So if you notice in our algorithm, that is exactly what we are going to do. So we have this recursive function which take nums and I, and we have this base case to, okay, let's not talk about the base case over here. First, in the temporary array, we are first going to push the current values, that is the current value of I. So when we call this function, right, so okay, I haven't written that. So when we call this function for the first time with the nums array and the 0 as the default value. So here in the temporary array, we're gonna say temp.push nums of I. So nums of I is 1, right? So as mentioned, either we can take 1 or we can not take 1. So I'm gonna first say just take 1 and push it to this temporary array and just call this again. So if you see over here, we are calling this function again. This right over here is basically our function that is being called, but with a new array called temp. And right now temp contains only 1 and the updated value of I, that is 1. Now why did we do this? Why did we do I plus 1? So that we can move to the next element. So we have already taken 1, right? We don't need to operate on 1 anymore. Now we need to take 2 or we need to reject 2. So again, in the next iteration, we're again going to do the same. But if you see below this, we're doing temp.pop. That is, we are rejecting 1. So in this one, we just added, so temp in the first case was this over here, but temp in the second case, that is temp.pop. So we removed the element from the temp. So now temp is empty. And now we are sending an empty array to this recursion. So this right over here will be f of empty array and I plus 1, that is 1 over here. Now, if you call this function again, you're gonna go back, you're gonna say temp.push nums of I. Now we are pushing the current I. So what is the current I? 1. And what is 1? 1 is the index of 2. So we are pushing 1 inside of this temp. So now you can see we can either take 2, we are taking 2 inside of it. So our array will look something like this. Or we can either reject 2, that is we are popping the 2 from the array. So we are removing the 2. In this case, our array will look something like this. And again, we are going to make the same function call in both of the cases. Similarly, in this recursive call as well. So I've actually written this completely. Let me just show you. Yep, there it is. I've written this complete diagram over here. So in the first iteration, we are either taking 1 or we are rejecting 1. In this iteration as well, either we are taking 2 or rejecting 2. In this iteration as well, we are either taking 3 or rejecting 3, right? And that is what we are going to do for all of these. And in the end, you're going to see we get all of these final elements as our answer. So this is what our answer will look like. This right over here, you can tally this with all of these results and you're going to find that's exactly the same. We haven't yet discussed the base case. So when we happen to reach this condition, that is I is equal to n, because we are increasing length of I every time, right? In this case, I is 1. In this case, I is 2. In this case, I is 3. So as soon as we reach the length of the array, that is when I is equals to nums.length, we're going to say, we're going to take this result array, that is the global array. We're going to push whatever we have currently in temp. So currently we had 1, 2, 3. So we're going to push that inside of this result array. So this is the, let's say, our result array. And we first pushed 1, 2, 3. Then again, we're gonna push 1, 2, and so on with all of these array over here. And then it's gonna give us this final result. So yeah, awesome. I hope you liked this explanation. Again, if you haven't yet subscribed to the channel, hit that subscribe button right now. And don't forget, Algo Agarwal needs to write code as well. So open your Instagram app right now and search Roadside Coder and message him to give Algo Agarwal opportunity to write code as well. Oh man, not again. Anyways, I'm just gonna go on and continue to explain you the code now. Since you already got an overview of, high level overview of the code, let me just quickly write that code down. So I'm gonna create a function over here called subsets. And as explained, it's gonna take an array called nums. Now we're gonna take a few variables. First of all is going to be result. Result will be an empty array. Then we're gonna have temp, which will contain the temporary elements of this array, that is the subsets of this array, and then we're gonna keep on changing the temp. Now next we're gonna create a function called, I don't know, let's say recursive subsets, and this will take nums and I, and in the end we're just gonna execute that function nums comma I and return the result. Don't worry, I'm going to explain everything step by step. So let's go inside of it. So we're going to start this by using our nums, that is our array over here, and the initial value will be 0 because that is where we are going to start. We're going to start from the first index, right? So we have provided the initial value of I as 0. Now let's just first get the base case out of the way. So simply I'm just going to say if it reaches the very end of the array, then we're going to return the result, right? So I'm just going to say if I is equals to nums.length, that if it reached the length of the array, then simply return result.push and whatever we have inside of our temp array. So our strategy was this, that either first we're gonna take an element or we're not gonna take an element, right, inside of the temp. So fine. So for the first element or for the current element, which is the 0th index, that is 1 over here, I'm just gonna simply say temp dot push. Either we're gonna take nums of I, right, or we're not gonna take nums of I. So first of all, we took the nums of I and we're gonna call recursive subsets with nums comma I plus 1. And next we're not gonna take it. So temp dot pop. So we're gonna remove it and then again call it recursive subsets nums comma I plus 1. So in both the cases, we're gonna move forward. We've took the first element and then we're gonna move on to the second element. And in this case, we didn't take the first element and then we're gonna move on to the second element. And again, these are going to branch out into different combinations, right? So yeah, this is how you run this algorithm. So let me just quickly grab it and console log and try to run this. And I'm gonna give this array over here to this one. And let's try to run this. And yep, there you see, we have all of the combinations of subsets for this particular array. If I just add one more number over here, it's gonna become huge now. Yep, you see, it gave us more combinations for this. But what if we just have one number? Yep, as expected. Oh, this is also running this previous algorithm. Let me just comment that one out. So yeah, that is it for this video. And if you like this video, give this video a huge fat thumbs up and subscribe to the channel for more such awesome interview videos. And if you haven't yet accessed the complete data structures with JavaScript series, click this card above my head to access the complete series.